Hello and welcome to I for Developers. I'm Chaitanya talking bot. Today's lesson is titled Key Concepts in RL. Agents, Environments, Rewards and Policies Explained. Imagine teaching a computer to play a video game. Not by telling it every single move, but by letting it try things out and learn from its successes and failures. That's reinforcement learning. RL. It's a powerful area of AI where an agent learns to make decisions by interacting with an environment to achieve a goal, much like how we learn to ride a bike, through trial and error. Getting positive feedback when we balance and negative when we fall. In RL, the asterisk agent asterisk is our intelligent entity. It's like the player in a video game, the robot navigating a room, or even a piece of software managing a stock portfolio. From a developer's perspective, you can think of the agent as the core algorithm or program you're building. It's the part that observes its surroundings, decides what to do next, and is ultimately responsible for learning. It's the brain you're trying to train. If the agent is the player, then the asterisk environment asterisk is the game world itself. It's everything outside the agent that the agent can interact with. This could be a virtual game level, a simulated robotic arm, or even a complex business system. The environment holds the rules of the game, responds to the agent's actions, and tells the agent what's happening. As a developer, you'll often be designing or defining this environment, setting up its rules and how it reacts. The agent and environment are constantly talking to each other in a loop. 1. The agent observes the current asterisk state asterisk of the environment. E.g., Mario is at position X. Y. A Goomba is approaching. 2. Based on this state, the agent chooses an asterisk action. E.g., Mario jumps. 3. The environment takes this action, updates its internal state, and presents a new state back to the agent, often along with a reward. This continuous cycle of observe state to choose action to get new state is the fundamental interaction that drives learning in RL. How does the agent know if it's doing well? Through asterisk rewards. After taking an action, the environment sends back a numerical value, the reward. Asterisk a positive reward means good job. Single quote, e.g., collecting a coin, defeating an enemy. Asterisk a negative reward, often called a penalty, means that wasn't ideal. Single quote, e.g., falling into a pit, losing health. Asterisk a zero reward means neutral, nothing special happened. The agent's ultimate goal is to learn how to choose actions that maximize the asterisk total reward it receives over time. As a developer, designing these rewards correctly is crucial for effective learning. The asterisk policy asterisk is the agent's strategy or rulebook that dictates what action to take given any particular state. Think of it as the brain or the set of habits the agent develops. Asterisk initially, the policy might be random, like a baby randomly flailing its arms. Asterisk through interacting with the environment and receiving rewards, the agent learns to improve its policy. It updates its rulebook to favor actions that led to higher rewards in the past. From a developer's standpoint, much of the RL magic lies in figuring out how the agent learns and updates this policy to become smarter over time. The entire objective of reinforcement learning is for the agent to continuously refine its policy asterisk so that it consistently chooses the best asterisk actions asterisk in any given asterisk state asterisk to maximize the cumulative asterisk rewards asterisk it receives from the asterisk environment. It's about figuring out the optimal strategy through experience, rather than being explicitly programmed with every rule. This learning by doing approach allows RL to solve complex problems where traditional programming would be incredibly difficult. As developers, understanding these core concepts, agent, environment, rewards, and policy is your foundation for building intelligent systems with RL. You'll be defining the agent's learning algorithms, designing the environment's rules, crafting the reward functions, and observing how the policy evolves. Whether it's for game AI, robotics, or complex resource management, RL empowers you to create systems that learn to achieve goals autonomously. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.